Alright, hi. We're going to do a review. This is a slideshow I made of the subcourse TM0656, Edition 4, Diesel Electric Locomotives, Army Professional Development, Army Correspondence Course Program. Alright, in the 1980s, Alfonso Villa de Rochas suggested several changes in internal combustion to improve the thermal efficiency. One change was ignite the fuel by heat of compression rather than by spark. In 1892, Dr. Ralph Rudolph Diesel adopted the idea, patented the engine that burned during the coal ignition ignited by compression. The coal-burning engine didn't develop as Dr. Diesel has hoped, but in 1897 he built another compression engine ignition, one that burned oil. Although various methods were used in transmitting the engine's power to the driving wheels, electric drove provided the most efficient combination of the diesel engine with the electric drive, known as the diesel-electric assembly. Applied to a locomotive, diesel-electric assembly may vary from model to model, but general construction principles are the same in all models. The first application of the diesel engine road stock is believed to have occurred in Sweden just before World War I. Then 1924, with the Ingersoll Rail and General Election American Locomotive Companies built a diesel-electric switching locomotive with the Central Railroad Company of New Jersey. Using the diesel-electric locomotive spread rapidly as it provided in the economy to ease the operation and maintenance. The first completed dieselized railroad was in Birmingham, Southern, in 1937. By 1955, the diesel-electric locomotives were operating at 88% of the passenger train miles and 85% of the total freight ton miles and 91% of the total switching hours of the United States Railroad. In 1968, all locomotives in the country of 98.5% were diesel-electric. Military road operations are different from civil operations. The United States military locomotives are used only for the training and hauling supplies from a commercial line into an installation. A theater operation, however, when the Transportation Railway Service operates a rail system that is used Army-owned locomotives. Those of the local railroads were possible. The text discuss diesel-electric locomotives is divided into two chapters. The first is devoted for the construction, the second for the maintenance, repair, and troubleshooting. Technical terms are used and explained in the glossary appendix 2 in the back of the text. When you finish studying this text, you should be able to name the components of a diesel-electric locomotive, to explain how they work, to maintain them and keep the locomotive running, and the troubleshooting of the various malfunctions. Chapter 1, Construction. 1.1 Introduction. Understanding what is wrong with the locomotive presupposes the knowledge of locomotive construction. If a repairman knows how the parts of the locomotive work, it is easy for him to discover what is wrong with them. But if he does not, maintenance or repair instructions seem difficult. For this reason, it introduces some of the terms commonly heard in the repair shop. The chapter contains a simple explanation of mechanical electrical principles applicable to diesel-electric locomotives. Section 1 discusses the mechanical construction of a locomotive, and Section 2 the fundamentals of an electrical system. Section 1, Mechanical Structures. 1.2, General. When the fuel is injected into the engine cylinder, heat is required to ignite it. In an automobile engine, high voltage from the battery pushes the current from the high resistance setup and the pressure of the combustion chamber and across one spark plug electrode to the other. The hot spark created by the initiated with the fuel-air mixture. There are often the other ways, however, to get the heat required for the combustion. For example, diesel engine uses compressed air, which heats as it is compressed. The two basic designs of diesel engines are a two-stroke and a four-stroke cycle. Both work on the same principle. Both variations due to the difference in their construction. The section discusses two designs. It describes the engine and the components, explains how they operate. It covers the fuel, the water cooling, and the oil air brake system, and locomotives and accessories. Figure 1.1, cut away the view and show the location of the various parts of the type of the diesel-electric locomotive. Alright, this is a cutaway view. There's 36 different parts: horn, steam generator, track, motor, blower. Number 2, hot water heater, electric cabinet, toolbox, cab heater, engine control, sandbox, and fillers, main generator, blower, auxiliary generator, main generator, and alternator, engine scavenging air blower, engine exhaust stack, diesel engine, diesel governor, diesel water pump, engine governor, engine water pump, lube oil strainers, engine cooling water tanks, engine temperature switches, lube oil cooler lube regulator, lube oil filter, air compressor radiator, engine cooling fan, air intake, cooling fan shutters, number of the box, classification light, cooling fan, contacting panel, handbrake, traction motor, and battery box, and fuel tank, water tank, and extra fuel tank. 1.3. The engine. A diesel engine is an internal combustion oil burning engine up using compression ignition. Such as an engine gets its power from burning a charge of the fuel while confined in a space called the cylinder. Ignition occurs when the fuel is ignited solely by the heat of the compression caused by the injection of the fuel into the highly compressed air in the cylinder. The engine is supported with a bed plate mounted on the locomotive frame, which serves as the housing for the crankshaft and reserves from the engine of lubricating oil. The main structural part of the engine and the cylinder block is shown in Figure 1-2. Between the inner and outer walls of the cylinder is a space water jacket containing water that helps to cool the engine. Here shows the cylinder head nut, cylinder head bolt in the cylinder, and the cylinder block. A diesel engine locomotive has essential same parts, work the same, and the major differences among them an arrangement of the cylinders. There are three most common cylinder arrangements of the V-type: the vertical line, the horizontal. The Figure 1-3 shows parts of the V-type engine, so called because of the arrangement forms of the V. It is used for the more powerful locomotives. The vertical in-alignment arrangement is used. This is the V engine. The A is the cylinder head cover. The B is the camshaft. C is the exhaust valve. The B is the cylinder head crab stud. E is the valve bridge. F is the hydraulic lash adjuster, cylinder head, exhaust valve, piston carrier, oil drain tube, piston pin, connection rod, blade connection rod. Piston cooling oil manifold, piston oil cooling oil pipe, oil pan, handhold cover, crankshaft, oil pan, main bearing stud, oil pan sump, main bearing cap, fork connection rod, basket connection rod bearing, crankshaft supply passage, water manifold, lubricating oil manifold, DD airbox, EE airbox handhold cover, FF cylinder liner, GG water drain pipe, the HH injector pipe, cylinder testing valve, cylinder head fuel oil, manifold, injector lathe shaft, injector adjusting link, and injector cab, injector rocker arm, and lubricating oil line, and overspeed trip rocker arm pawl. Most in the lower power engines, the horizontal arrangement is where the flat underflowing mounting is desired. Moving up and down inside the cylinders is the piston connected by the connecting rods to the crankshaft. The crankshaft is shown in Figure 4.1.4. Transmit the mechanical action from the piston to the drive to the generator. The generator changes the mechanical action into the electricity transmitted through the cables. The traction motors, which change it through a gear of arrangements back into the mechanical force to turn the wheels. This is the crankshaft. It shows the crankshaft, generator flange, split gear, center journal, and shaft flange with the main bearings and the counterbalance bearings. 1.4. Engine action to produce the power through the interval of time. A diesel engine must perform a definite series of operations over and over again. The series is known as the cycle, with the suction, compression, ignition, exhaust. It takes place in order to list the engine and requires the 4 strokes from the piston, 2 revolutions crankshaft to complete a cycle. It is also known as a 4-stroke cycle engine, 1 completing with the cycle into 2 strokes of the piston and 1 revolution of the crankshaft into a 2-stroke engine. Illustrates an operating cycle with the 2 types of engines. In the 4-stroke cycle engine, air is drawn into the cylinder through the intake as the piston descends into the intake stroke. The intake valve then closes and the piston goes up into the compression stroke. The compression of the air within the cylinder for the fuel is injected with the injector while the air is compressed and combustion occurs. The combustion with the resolution pressure drives and the piston back down in the power stroke. The power piston rises the exhaust stroke and expels the air through the exhaust valve as process called the scavenging. At the top you see the 4-stroke cycle with the exhaust intake valves and the injectors, intake, compression stroke, power stroke, exhaust stroke. In the 2 cycle you see the exhaust valve and the injector with the intake ports and the injection different to the 2-stroke intake, exhaust, compression stroke, injection, combustion, and expansion stroke. Pistons and cycle engines basically the same. Different in the scavenging make accounts with the two-stroke rather than a force. Air entering the intake of the port pushes the oxygen depleted for the air left in the previous combustion out of the exhaust valves. The compression stroke then occurs. And notice that in the lower portion of Figure 1.5, the piston itself closes intact. It closes the intake port on the stroke. 1.5 pressure charging. And ordinarily enters the cylinder of the atmospheric pressure. The amount of the fuel entering cylinder is therefore limited because it has related to the amount of the oxygen available to mix. If too much of the fuel enters in the cylinder left unburned, it settles on the cylinder wall and piston dilutes in the lube oil film. This prevents a tight fit and causes the leak air and lost power. Therefore, the amount of the entering fuel must carefully regulated. Also, it must enter the cylinder so that the first fuel entering begins with the burning before the rest of the fuel enters, providing gradual, even combustion. If the fuel enters the cylinder before the ignition begins, it also burns once and explodes. A loud knocking of the explosion, called combustion knock, occurs. A pressure-charged engine provides a method of putting the more air and more fuel and resulting in greater power into the cylinders. By this method, sometimes called supercharging, power can be increased 50% in the four-stroke engine and 35% in the two-stroke engine. Extras air is made and they enter the intake valve and the intake port of the compression. A number of air compressing devices have been used in the furnishing the supercharging air. This kind of most commonly used is electric locomotive is turbine compressor operated with a gas turbine in the exhaust system. This is most logical place of the turbine because of the great deal of energy wasted through the exhaust of the burned gas. Heat balances figures show the loss to be as much as 40% of the energy liberated from the fuel by the combustion. This energy is captured to run the turbine, which is connected to the compressor that delivers air under the pressure to the engine. 1.6. The fuel system, often referred to as the heart of the diesel engine, squirts the proper amount of the fuel cylinder at the proper time. The most important part of the system is the injector, which measures the right amount of fuel, injects into the cylinder under the high pressure, reduces it to the fine spray. Other parts of the fuel system are then a tank to hold the fuel oil pump driven from the motor to get from the oil to the tank to the injectors. Filters clean the oil as it passes through the system, and an injection nozzle to direct the fuel for the combustion chamber in the best pattern. For the combustion emergency fuel cutoff valve to stop the fuel from flowing from the tank into the emergency. Generally speaking, fuel begins entering the combustion space in the cylinder when the piston is about 15 degrees before the top dead center. When the kindling combustion temperature of the fuel is reached, the spray drops of the fuel begins to burn. The fuel is still being injected, but it burns as soon as it leaves the injection nozzle. When the fuel is delivered by the injection pump under the sufficient pressure, the nozzle valve lifts against the spring pressure. Fuel enters in the nozzle, sprayed from them into the combustion chamber. Several types of combustion chambers are used. The simple type, of the one most commonly used in the military diesel electric, is the direct and open chamber, illustrated in Figure 1.6. The entire supply of air is in the cylinder with a depression of the piston crown, providing the combustion space with the types of combustion chamber, heat loss, and small fuel consumption low. Also, the engine can start quickly during cold weather. The fuel tank. The fuel tank is contained with the tank fitted with the baffle plates to prevent surging and with a pit to catch the sludge, whether they can be drained out or since the fuel pumps alone cannot raise the fuel to cylinder intake port. To the alternative method of supplying fuel can be used. A small service tank can be located above the pumps and fuel can enter the pumps in gravity. If the service tank is not used, the fuel can be pumped from the main tank and the mechanically electrical pump. Figure 1.6 shows the open combustion chamber. The fuel injection illustrated in Figure 1.7 now only creates the injection pressure determined by the amounts of fuel injected. Its tooth rack, controlled by the engine governor, and the speed control lever verifies the amount of the fuel, actuates all the pump elements of the pumps, the primary piston and plunger sliding in the barrel. The lower end of the plunger has the two projections where the engine slots of the control sleeves. Oils enters into the intake is trapped between the helical groove and the slots whenever it rises to the cover of the split port. Various positions of the groove slot are shown in Figure 1.8. Position A shows the plunger in lowest point, and Position B shows it when its both ports are closed during its rise. Cylinders, Position C and D and E show the plunger when the locomotive is fully loaded, half loaded, and idling. When the locomotive is at full stop, the plunger is at Position F. Figure 1.7 shows the fuel injection pump. From the right, the spill port, helical groove slot, control sleeve, plunger projections, and the tooth rack with the intake port on the left side. The fuel filter, since the dust and the grits in the fuel in the main cause the diesel engine trouble, the most important of all precautions is fitting the efficient filters with the fuel oil supply line. The equipment is quickly run with the fine particle for the dust and grit allowed to enter the fuel line. Irregular running loose of the power and pour fuel metering starting with the result of the plunger in the fuel pump with the helical opposite with the split port are usually warm with first when the dirt is in the fuel. Figure 1.8 shows the position A, B, C, D, and E and F of the valve. Fuel metering. Most diesel engines are two kinds of fuel filters, primarily the coarse and primary of coarse filter between the supply tanks and the fuel supply pump. A main or fine filter becomes the fuel supply pump and the injection pumps. They are made with either metal or fabric. The metal filters are used primarily filters because of the fine particles that use through them are not as harmful as supply pump that made with the injection pump. The clean and by scraping with metal discs because of their greater filtering qualities. Fabric filters are usually used in the main filters to protect fuel injection pump. They have bags which are turned inside out to get rid of dirt and then washed and reinstalled. 1 and 7, water cooling system. The heat originating in the oil engine is absorbed, circulating the water dissipated within the fan-cooled radiator. The diesel electric locomotive of the fan is driven by a motor powered with the auxiliary generator. Since the heated water helps the engine to reach its best operating temperature more quickly. The radiator is not brought to the water circuit. The water circuit is quite hot. Temperatures of the water can be regulated with levers on the front of the radiator. The water circulated by the pump, driven by the engine, it goes through the water jackets between the cylinder and cylinder liners, then is routed through the radiator to be cooled. With a well-regulated radiator, water enters at the engine at 100 degrees to 120 degrees Fahrenheit, leaves at 150 180 degrees Fahrenheit. Because the heat and causes the metal to expand, the contract is better than a high rate of water circulation with a small difference in temperature of water entering, leaving the engine, then circulating the water more slowly, having the larger difference in entering, leaving, and temperatures. Water in the cooling system is treated to remove the hardness, minimize the corrosion, to remove the suspended impurities. Hardness, in term used to express the presence of scale-forming salt of the raw water, can be removed with the water softener. Dry compounds should be poured into the radiator as they may be clogging the system. Water should be treated in separate containers. First, solids allowed to be settled before drawing solutions of the engine. In treatment, improper, ineffective radiator water jackets will become clogged and cylinder liners corroded. 1.8 Lubrication system. Sometimes oil used for the cooling as well as lubricating. When it is done with the separate oil radiator, will only cool fan is provided with the main radiator. Using the bearing lubrication, oil circulation rate lower than when it is used with the piston cooling lubrication. Oil hits outside of the piston with a fine spray of the crankshaft bearings, the operating gear, camshaft. They are lubricated by oil under pressure. Without pressure, the free return oil lubricates with the camshaft driving the gears and cylinder walls, contaminating the particles can usually be filtered out. Some contaminations of oil are inevitable. For example, the oil itself oxidizes the corrosive acids. The acids prevented with the harming the engine by additives with either keeping the oil with the oxiding provided with the protective coating on the other parts of the touch. In addition, the oil should be possess some of the detergent properties to keep the containing matter in suspension that will be drained off with the crankcase is drained. Contaminants materials found in the oil may be any of the following metals bits caused by the wear of the engine. Carbonaceous particles result in the fuel incorrectly burned and caused by the breaking of the oil itself. Unburnt fuel, cooling water that has leaked in, and the acid water caused by the cooling of the burnt gases which is passed by the piston. B. Filters. Oil circulation pumps are protected with the contamination gauze screens that by removing the heavier substance from the oil and smaller particles are removed from the metallic strainers made with the fine very gauze, steel wool, and closely spaced plates. The finest materials of the carbon carried out with the suspension in the oil are removed by the absorbent filters made with the special papers, cotton or felt. Two methods of routing the oil through the filters are used. The full fuel full floor filtering, which passes the oil through the filter, and by filtering, where only part of the oil is continuously bypassed through the filter. Flow filters have relief valves that can open and take the oil out of the filter's path when the pressure drops across the filter is excessive. 1.9. The air brake system. Air is supplied by an air compressor. It is used to operate the brakes on a military diesel electric locomotive. The air brake system is made to use the compressor to supply with the two main reserves to cool and store, and is the lever controls the compressor pumping, and it also consists of the braking cylinder, mechanical linkage valves, piston rods, and brake cylinder connected through the brake levers to the brake shoes. Air pressure forces the piston out of the transmitting of the forces through the rods and levers of the brake shoes, applies them to the wheels. Several kinds of the air brakes used in the diesel electric locomotive, clearly distinction made among them, controlled by the levers, operators, cabs, and air brakes to the automatic independent combination of the two. On locomotives used with the Foreign Service, a vacuum brake in the system is used. The automatic brakes control both the locomotive and the train. The pressure is maintained of the brake pipe the entire time the train is operating. Reducing the pressure applies the brakes, returning them to the normal, releases them. On each of the train, an auxiliary reserve holds the air brake and the brake cylinders. The air in the cylinder is used to activate the brake linkage. B. The independent brake controls only the locomotive. They are generally used for yard switching services for the trains of fewer cars, but the car brakes do not operate, resulting in a rough operation and slow stops. C. An independent and automatic brakes are sometimes used in the great control as possible. The two systems are completely separate and have separate controls. D. In the vacuum brake operation, the compressed air brake and the pipe is cut out with the vacuum brake valve connected to the locomotive and the train. Automatic brakes are then controlled by the vacuum brake valve. Independent brake by the independent brake valve handle. The military road switcher to the other diesel electric locomotives in the military fleet designed for the Foreign Service of the vacuum brake valves can have them installed to handle the trains with the foreign countries when most cars have vacuum brakes. 110. Air brake equipment. In addition with the compressor, the governors, the reserves, and the valves previously mentioned, all air brake systems have many other parts. Typically, examples of these are cutout cocks, pressure gauges, equalizing reserve, distributing feed, reducing quick release valves, and dead man controls. These are discussed in the following subparagraphs. Cutout cocks are used by the bypass part of the circuit when they are not needed. Two pressure gauges are common in the air brake system. One indicated the main air reserve and the equalizing reserve pressure. The other shows the locomotive with the brake cylinder and the brake pipe pressure. C. An equalizing reserve adds the volume to the space when the equalizing piston and the brake valve, so that the reduction of the brake pipe pressure may be properly during the service applications of the brakes. D. The distributing valve, when actuated with the brake valves, permits the air to flow. The locomotive brake cylinder maintains the pressure against the leakage, when brakes are held in the applied position, permits the air to exhaust the atmosphere when the brakes are released. A feed valve automatically maintains the predetermined air pressure in the brake pipe. F. A reducing valve reduces the main reserve pressure for the independent air brake operation, for an air signal system. The quick release valve provides a rapid release of the brake cylinder pressure during the release of the operation. And H, the dead man control, is a safety device which means that the pressure of the locomotive is in the operation, released only when the air brakes are to be applied. Release of the dead man pedal causes the warning whistle to sound approximately 4 seconds after the brakes are automatically applied. Automatic application of the brakes can be avoided, but the pedal is pressed in during the warning period. 11. The trucks. Trucks consist of the side frame, wheels, axles, journal boxes, bolster, springs, bearings, brake rigging. Besides the connecting wheels, the locomotive the truck carries most of the vertical weight, absorbs lateral thrust, supports the tilting tendencies of the locomotive, travels on an uneven track without distortion, carrying the brake rigging on the some of the locomotives, and carrying the traction motor. A part of the guides and called pedestals are supported by the side of the frame holes of the journal boxes. Some of the locomotives have chains attached to the underframe to the truck to limit the swinging in the truck of the causing derailment. The swivel truck is shown in the figure 1.9 is used on all but smallest diesel electrical locomotives. Each swivel truck has a central plate which supports the locomotive frame superstructure and allows the truck to turn freely on the curves. Tilting the superstructure is limited with the side bearings mounted between the underframe of the truck frame. This principal types the swivel trucks and the locomotive's largest 40 tons of the 4-wheel rigid from 4 and 6-wheel swing bolsters. All right, this shows the swivel truck from the top. On the left and right, 12 o'clock, center plate, brake cylinder, truck wheel, traction motor, power cable, brake hanger, brake shoe, truck axle, frame and box, journal box, brake lever, and journal box and brake cylinder and bolster. A rigid truck, a bolster, and the frame are the cast together with the swing bolster truck. The bolster independently suspends and can absorb some of the shock between the truck and the body. For the reason the swing bolster truck is more suited for the heavy road surfaces because six-wheel swing bolster trucks have additional wheels. The locomotive weight is distributed more evenly among the rails. Some of the six-wheel trucks use four wheels as driving wheels and two as idling wheels, while other six-wheel trucks are all six driving wheels. Idling wheels merely help to equalize the weight of the distribution of the locomotive. 112. Accessories. The locomotive engine supports the various accessories such as the horn, windshield wiper. These actuated by either mechanical or electrical means to parts of the engine. The bell, signal bell, is a stationary movable clapper operated by an air valve located with the engine's man station. The bell is usually located under the floor behind the floor switchman footboards on the right side and the front end of the locomotive. B. The horn. The horn operated with the air valves allowed the air brake to be forced with the sounding of the devices mounted on the top of the cab, controlled by the two pull cords with the above control stand. On one cord gives the soft tone, on the other full tone. The horn shuts off, cuts in the airline above the floor in the front of the controller. The airline supplies the horn valves with air. The speed recorder. The speed recorder, similar to the speedometer, can be operated with the hydraulic, manually, electrically. The windshield wipers are operated by either the compressed air system or the control valve by the valves over the cab windows, operated independently of each other, and windshield wipers should never be run on a dry window as the dirt on the window will scratch the glass. E. Sanding system. A sanding system delivers between the wheel and the rail. It is three parts: sand trap, control valve, operating device. Sand is kept in the box. Flow from the sand trap pipe of the rail. In some locomotives, the sanding system can be operated by the automatic brake valve. In others, it is operated by hand. F. Temperature controls. On large locomotives, water temperature and engine cooling system is regulated automatically. When water temperature changes, the thermostat operators switch actively the fan motor contactors. As temperature increases, the medium speed relays closest further increase closest of full speed. Relay. The temperature drops and the same operation takes place in the reverse order. The same engine cooling fans of motor driven receive the power from the alternating current generator. Various combinations of the fan control contactors provide the fan operation with the traction motor circuit. The power is transmitted to drive the cooling fans through the magnetic clutch called the eddy current clutch. Fan speeds are varied by the changing of the excitation of the field coils on the clutch. Other engine cooling fans are mechanically driven. G. Engine heaters. Oil-fired engine heaters are provided with the operation in several cold weather. The cooling, lubrication, fuel, oil system batteries must be performed before starting the engine and power along and has resulted in congealed fuel, oil, lubricating oil. Continued operation of the heaters is necessary after the engine has started. The special installation of oil lines, tanks, compartments is part of such an installation, often called the winterization system. The heaters are useful and the main locomotive of the fuel oil system, but the small tank of the heater automatically kept full. The reverse supply of the fuel may even be heated before the operating. The supply of the heat through the hot water piping system or an exhaust gas system to the power plant. Essentially, the auxiliary equipment, an electric motor which obtains the power of the from the locomotive's auxiliary power lines, driven with the fuel pump, water circulating pump, and the blower. The fuel oil is ignited with the fire pot and the continuous electric spark. The equipment does not eliminate the need of the draining of the cooling system, keeping it filled with an adequate antifreeze solution when the locomotive is shut down. H. The cab heater. The cab heaters are installed on most locomotives to keep the cab comfortable in cold weather. The heat and with the hot water, electrical, and hot air, the hot water heater is connected with the engine water system with the supplies of the heat. A small electrical fan is built with the heater to circulate the air over the water coils into the cab. The heater is switched into the cab connections. The fan auxiliary power lines. The fan speeds verified by the rheostat incorporated with the switch. The cocks are provided with the shutting off of the flow of the water and draining the heaters. And all electric heater is essential but the same with the hot water heater, except for the heating element is electrical coil. The electrical defrost, which works on the same principle, have a separate control switch. Hot air heaters consist of ducts through hot air of the engine radiators is forced into the cab windows. 113 summary. A diesel engine can either be two-stroke, four-stroke, except for its ignition is most likely another internal combustion engine. It's one of three types: vertical inline, or horizontal, depending on the arrangement of the cylinders. Fuel system includes the fuel tank, fuel ignition, fuel pump, ignition pumps, filters, injection nozzles, emergency fuel cutoff valve. The fuel tank has baffle plates to prevent surging in the pit, to catch sediments to be drained out. In so much locomotive fuel tank is above the pump, and the fuel enters the pump. And gravity and other fuel pump is fuel tank of the main pump, the auxiliary pump. The fuel pump creates injection pressure that determines the amount of fuel injected in the cylinders by the injectors. In the engine with the water cooling system, the water is running through the water jackets between the cylinder and the cylinder liners. The water is directed through the radiator to cool it. Levers or on the front of the radiator can open and close to regulate the heat of the escaping from it. Occasionally, the engine is designed so that the pistons are cooled by their lubricating oil. When this is done, special oil radiator. When this is oil cool fan provided with an additional water cooling radiator. Lubricating oil should have some detergent properties so the contaminating materials can be kept in suspension filters out of the strainers made out of the gauze and steel wool closely spaced plates. Brakes from the locomotive can be the kind of the control locomotive and the train, or both, and air pressure from the brakes are supplied by a compressor. The weight of the locomotive is carried by the trucks and absorbs lateral thrust, opposing the tilting of the tendencies. The track is made of the front frames and the wheels, axles, journal boxes, bolsters, spring bearings, brake rigging, and most of the locomotives are equipped with the chain limits of the swing of the trucks in case of the derailment. Locomotives larger than 40 tons of the four-wheel rigged trucks and four-wheel swing bolster trucks, six-wheel swing bolster trucks, accessories supported with the locomotive engine, including bell horn, speed recorder, windshield wipers, sanding system, temperature controls, and engine cabin heaters. Section 2, Electrical System.